Today we're going to focus on graphing square root functions. When we're doing this, here is our original form of the equation. F of x equals the square root of x. So we're going to have some value of x. We can substitute that in and figure out what our value of f of x, or y, can be. So let's start by just thinking about our perfect squares, because we're going to be taking the square root of a whole bunch of stuff. Well, we can take the square root of 0, that's just 0. The square root of 1 is 1. Then our next perfect square would be 4, because the square root of 4 is 2. Then 9, square root of 9 is 3. Then 16, we could go into 25, 36, 49, 64, and so on and so on and so on. So now let's go ahead and substitute those in. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. So these are all going to be a bunch of ordered pairs for our graph. Let's go ahead and plot those points. We've got 0, 0, 1, 1. Then our next x value is 4, and we go up to 9, 3, and 16, 4. And when we put all of those together, here's what our graph looks like. So this is the parent function of square root graphs. We start at 0, 0, and then it kind of starts to go up, but then slowly starts to flatten out. And if we were to keep going, it would get flatter and flatter as we keep going outward. Now over here on the left, I have this thing called the normal movement, which is just the movement from the origin for each point in my parent function for square roots. So from the origin, to get to a new point, I would go to the right 1 and up 1, which is exactly what we did. Then I would go to the right 4 and up 2. To the right 9, again, we're starting at the origin each time. To the right 9 and up 3. From the origin to the right 16 and up 4. That's my normal movement for my parent function, and I'll explain why I'm saying that in just a second. Our domain. The domain always goes from the left to the right. The farthest to the left that this graph gets is at an x value of 0. And it's a filled-in circle, so it gets a bracket at 0, and then it's going towards infinity, going to the right forever and ever and ever. Then our range, the lowest that this graph gets, the lowest y value, is also at 0, and this arrow is going upward forever and ever and ever, so our range is from 0 to infinity, where 0 is included.